So for the first one here, we have to combine what we can on each side. So we're going to start out on the left side over here. Um, Whenever we see parentheses, it should scream at us to do something there first. There's a couple set of parentheses on the left side, so we're going to work left to right. So we look at this one. There's nothing we can do inside there. 3x and negative 2 cannot be combined. So we'll multiply by the 4. 4 times 3x is 12x. 4 times negative 2 is negative 8. Next set of parentheses here, once again, there's nothing we can do inside there. 2x and a positive 1 cannot be combined. So we're going to multiply, and here's where we have to be careful. We're multiplying by a negative 5. Negative 5 times 2x is a negative 10x. And negative 5 times 1 is a negative 5. The 3x over here is not in any parentheses, so it does not get multiplied, but it's still there. Now let's continue to work on the left side here. We have more that we can combine. 12x and negative 10x make 2x, plus 3x is 5x. Negative 8 and negative 5 is a negative 13. So 5x minus 13 on the left side is as far as we can combine it. There's nothing more we can do. So let's go to the right side. On the right side here, we have parentheses as well. So we're going to work our way left to right. First one here, 5x minus 8. We cannot combine that, so we can't do anything inside the parentheses. So we'll multiply by 2. 2 times 5x is 10x. 2 times negative 8 is a negative 16. Next parentheses, 2x minus 5. Again, there's nothing we can do inside there. 2x and negative 5 cannot be combined. So we're going to multiply by, once again, we got to be careful. We're multiplying by a negative 3. Negative 3 times 2x is a negative 6x. Negative 3 times negative 5 is a positive 15. Now this negative 5 is outside the parentheses, so it does not get multiplied by anything. Now we can combine. We got 10x and negative 6x is a 4x. Negative 16 and negative 5 is a negative 21. Oops, forgot the 15 there, sorry. We have negative 16, and 15 is negative 1, and negative 5 makes a negative 6. So 4x minus 6 there. Now we've combined everything we can on each side. We need to make sure that the variable is on only one side. Right now it's on both sides, so I have to get rid of one. The smaller one will be the 4x. It's positive, so I'm going to get rid of it by subtracting. I have to subtract 4x from the other side as well. I can only take it from the 5x. 5x minus 4x is 1x, or just x. We still have the minus 13, and it equals negative 6. So now we're ready to solve. All we have to do is add 13. X equals negative 6 plus 13 is 7. So we get x equals 7 there. Well, a lot of steps, but again, not terrible to solve. Number 2 over here looks ugly because of the fractions, but it's really just a simple two-step equation. We are going to have to add 3.5 to get rid of the minus 3.5. So that's gone. We're left with 1 1/3 x equals, so 5 3/4. I'm going to write it off over here, plus 3.5. We need common denominators, which is going to be 4. 1/2 becomes 2/4. 3/4 stays 3/4. We add 3 and 2 make 5/4, which is 1 1/4. So I'm going to keep the 1/4, carry the 1. 1 and 5 is 6, plus 3 is 9 and 1/4. So 1 1/3 x equals 9 and 1/4. And now my final step to solve that is going to be to divide by 1 1/3. So I have x equals 9 1/4 divided by 1 1/3. Our first step is to make them improper fractions. So 9 times 4 is 36, plus 1 is 37 fourths. Divided by 1 times 3 is 3, plus 1 is 4 thirds. Tempted to cross cancel there, but it's division. We can only cross cancel when it's multiplication. So the 37/4 doesn't change. We're going to multiply by the reciprocal, so times 3 over 4. Now we could cross cancel, but unfortunately nothing cancels out. 37 times 3 is 111. 4 times 4 is 16. And now we need to reduce that. So 111 divided by 16. 16 does not go into 1. It does not go into 11. It does go into 111 6 times. 6 times 16 would be 96. So that would be 15 left over. So 6 and 15 sixteenths. So x is 6 and 15 sixteenths. Again, it's just 2 steps. We just added and then divided. But of course, it was a lot of extra work because we had to deal with the calculations with the fractions. Now, in an equation like that, we have an alternative. If we really, really, really do not want to work with the fractions, we can find a least common denominator. So we look here, we've got denominators of 3, 2, and 4. The least common denominator for all 3 of them. In other words, the smallest number that all 3 of them will go into. So the common denominator has to be equal to or greater than any of the denominators we're looking at. 2 goes into 4, so anything that 4 works for, 2 will work for, so we don't have to worry about the 2. For 3 and 4, that least common denominator would be 12, and 2 works with the 12 as well. So now what we can do is we can go back to our equation here, and we can multiply that equation by 12. What I mean by multiplying the equation, I mean every digit in that equation is going to have to get multiplied by the 12. So 12 times 1 1/3 x. So 12 over 1 times 1 1/3 x. We still have some work to do because the 1 1/3 has to be changed to 4 thirds. And we're going to put the x on top. So 4x over 3 or 4 thirds x. So now we can multiply 12. Well, I can cross cancel here. The 12 and the 3 both divide by 3 to give me 1 and 4. 4 times 4x is 16x over 1. So that's just 16x. Next, we can do the 12 times a negative 3.5. So again, we'll make this 12 over 1. 3 times 2 is 6, plus 1 is 7. So that's going to be, we're going to put the negative with the 7, negative 7 over 2. $12 and 2 cross cancel. They both divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So 6 times negative 7 is a negative 42. 1 times 1 is 1. That's just going to be a negative 42 equals. Finally, we do the 12 times the 5 3/4. Well, we'll make this 12 over 1. 5 3/4 has to become improper. So 5 times 4 is 20, plus 3 is 23 over 4. And the 12 and 4 cross cancel, both divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 times 23 is 69. 1 times 1 is 1. So that's just going to be a 69 here. Now we have an equation that has no fractions in it. We can go ahead and solve. So I'm going to add 42. I get 16x equals 111. And we'll divide by 16. So the 16 cancels out there. We have x equals 111 over 16. We still should treat that like an improper fraction. Remember, we've said that division and fractions are very closely related. We can switch back and forth from one to the other pretty easily. So 11 divided by 16 is going to be treated as 111 divided by 16 is going to be treated as 111 sixteenths. And we're just going to reduce that into a mixed number. So as we saw before, 16 goes into 111 6 times. 6 times 16 is 96. We subtract there to get 15. So that is 6 and 15 sixteenths. Whether you think that process is easier or not, for this equation, I think it's almost more work because you've got to multiply 3 times there, 3 sets of fractions and mixed numbers. But it does get rid of the fractions and get you to an equation where you can work without the fractions. Now, of course, here we still had to go back to the fractions for our final answer. If you were going to double check it, if you're going to take this answer and plug it back into the equation to make sure it worked, you would still want to go back to this original equation. Just because there's a lot of steps here, the chances that something went wrong, you'd rather check it back in an equation that we know is correct. Now, this process is multiplying by that least common denominator to get rid of the fractions. Has a place. I mean, there's some equations where it is easier. For an equation like this, x over 4 plus x over 7 equals 22. There are 2 ways we can approach this. X over 4 can be thought of as 1/4 x. Why? Well, 1/4 times x is going to be 1/4 times x over 1. 1 times x is x, 4 times 1 is 4. So 1/4 times x and x over 4 are the same thing. So the x over 7 can be thought of as 1/7 x equals 22. Now at this point, this is the same as having like 3x plus 5x equals 32. Here we would have added the 3x and the 5x to get 8x. We're going to do the same thing here. We're going to add 1/4 x and 1/7 x. However, 1/4 and 1/7 require a little bit of work to combine. Common denominator would be 28. So this is 7 28ths, 4 28ths. Well, 7 28ths plus 4 28ths is 11 28ths. That's 11 28ths x equals 22. And now we solve by dividing by the 11 28ths. First, they cancel out on the left side. X equals 22 divided by 11 28ths. Well, first we make that 22 over 1. And we're going to multiply that reciprocal, 28 over 11. We can cross-cancel the 22 and 11. They both divide by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. 2 times 28 is 56. 1 times 1 is 1, so that x equals 56 is our solution. Now, here's a case where multiplying by that least common denominator may have been simpler. Our least common denominator was 28. So to multiply 28 times x over 4, well, 28 over 1 times x over 4 28 and 4 cross cancel. They both divide by 4, giving me 1 and 7. 7 times x is 7x. 28 times x over 7. Well, 28 over 1 times x over 7. Again, 28 and 7 cross cancel. 7 divided by 7 is 1. 28 divided by 7 is 4. 4 times x, it gives me 4x. And 28 times 22 should be 616, but I'm going to double check on the calculator, and we do get 616. Now we have a pretty simple equation to solve. 7x plus 4x is 11x equals 616. And we'll divide by 11. X equals 56. There are some equations we run into where we don't have a choice. We have to multiply. We saw this equation yesterday. Here, this whole left side is being divided by 4. So to solve this, the first thing we have to do is multiply by that 4. Makes the 4 go away. 3x plus 7 equals 7 times 4 is 28. Now it's one of those equations, that two-step equation that we can solve. Subtract 7. 3x equals 28 minus 7 is 21. And divide by 3. Get x equals 7. Very similar to that would be an equation that looks like this. 2/3 x minus 1/4 over 7/8 equals 4/5. Here again, this whole left side is being divided by the 7/8. So we're going to start to solve it by multiplying by 7/8. So on the left side, the 7/8 cancels out. We have 2/3 x minus 1/4 equals. Here the 4's cross cancel, or 4 and 8 cross cancel. Both can be divided by 4 to give me 1 and 2. So 1 times 7 is 7, and 5 times 2 is 10. 7/10. Now we will add the 1/4. So on the left side, we just have 2/3 x. On the right side, we need a common denominator, which will be 20. 10 times 2, so 7 times 2 is 14/20. 4 times 5 to make 20, so 1 times 5 is 5/20. 14 plus 5 is 19/20. Now we'll divide by the 2/3. X equals, well, 19/20 divided by 2/3 is going to be 19/20 times 3 over 2. 19 times 3 is 57. 20 times 2 is 40. 40 goes into 57 once with 17 left over. So 1 and 17/40. There are other equations that have fractions in them that are not as subtle as these last couple. You know, here we just had that extra denominator. We just had to multiply by that number. But there will be others where we actually have to search for that common denominator, like we did in the first couple of examples. It might look like this. 4x plus 3 over 3 minus 2x minus 3 over 9 equals 6x plus 4 over 6 plus x over 3. So now here we have fractions everywhere. The easiest way to deal with this is to multiply by that least common denominator and get rid of the fractions. Now, first thing I should point out to avoid mistakes, we're going to change this here to plus a negative 1 times the numerator. Now remember, negatives and a fraction either go with the numerator or denominator, but not both. Because if they're both negative, that becomes a positive. So now our least common denominator here. We have 3, 6, and 9. Well, 3 goes into both 6 and 9, so anything that works for 6 and 9, the 3 will work for. Looks like we're going to go with 18. 6 and 9 both go into 18, and 3 goes into 18 as well. So we're going to multiply this whole equation by 18. So we have 18 times, we'll make it 18 over 1 times 4x plus 3 over 3. Now I'm going to do two things here. I'm going to put the 4x plus 3 in parentheses. And now I'm going to cross cancel the 18 and 3. Both of them divide by 3. 3 divided by 3, of course, is 1. 18 divided by 3 is 6. Now on the denominator, I just have 1, so the denominator is pretty much taken care of. The numerator, we still have to distribute the 6. 6 times 4x, 24x, and 6 times 3 is a positive 18. This next one's going to be a bit trickier. We have 18 times the negative 1 times the 2x minus 3 over 9. Well, let's still cross-cancel the 18 and the 9. Both of them divide by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. Now I'm going to do the 2 times the negative 1 here is negative 2. And I'll distribute now the negative 2. On bottom, I see I have all 1s. So the denominator, again, is taken care of. It's a 1. Negative 2 times 2x is a negative 4x. Negative 2 times negative 3 is a positive 6. That brings us to the equal sign. We'll have 18 times the 6x plus 4 over 6. So we'll make that 18 over 1 times the 6x plus 4 over 6. Again, we're going to put parentheses around the numerator there, and we're going to cross-cancel this 18 and 6. Both divide by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. Again, the denominator is 1, so we don't have to worry about that. We distribute the 3. 3 times 6x is 18x. 3 times 4 is positive 12. And finally, we have the 18 times the x over 3. 18 over 1 times x over 3. We'll cross-cancel the 18 and 3, both divide by 3, giving me 1 and 6. So 6 times x is 6x. Well, now we have this equation, which is not pretty yet in itself. It's still pretty ugly, but there's no fractions. So we have to combine on the left side here. We have 24x and negative 4x is 20x. 18 and 6 is a positive 24. On the right side, we have 18x and 6x is 24x. And plus 12, positive 12. Now we've combined what we can on either side. We need to make sure the variable's on only one side. Right now it's on both. So we'll get rid of the smaller one is the 20x. It's positive, so I'm going to subtract it. Subtract 20x from both sides. Now I have 24 equals 24x minus 20x is 4x plus 12. Now we're ready to solve. We are going to subtract 12 from both sides. 24 minus 12 is 12 equals 4x. The 12 is canceled out. And we divide by 4. 12 divided by 4 is 3. So 3 equals x. Now there is another way you could have solved this. You could have taken each piece up here and divided it. Let me show you what I mean by that. I'm just going to start this equation. I'm not going to go through all the whole process because there's going to be a lot of fractions in here. So what we could have done is this. We could have done 4x divided by 3 is 4/3 x. 3 divided by 3 is positive 1. Now here we would have put the negative probably with the 9 instead of on top. 2x divided by negative 9 is a negative 2/9 x. Negative 3 divided by negative 9 is a positive 1/3. Equals, on the other side, 6x divided by 6 would be just x. 4 divided by 6 reduces to 2/3. And x divided by 3 is a 1/3 x. And then we could have solved that equation. But there's a lot of fractions. If you're good at working with fractions, this is probably an easier way of doing it than multiplying by the 18 to get this. Because you saw multiplying by that 18, there's a lot of cross-canceling and distributing and stuff. It wasn't necessarily easy to do. It's just a way of getting rid of the fractions. There are some equations where we have no choice. We have to use that common denominator. These equations would look like this. You see here the problem is the variable is in the denominator. We cannot solve equations that have the variable on the bottom of the equation, on the bottom of a fraction. So we have to change it so that's not the case. The way we do that is a least common denominator. Here we have denominators of x, 6, and 3x. If I look at the numbers 3 and 6, the least common denominator is going to be just 6. This 3 goes into 6. For my variable, x, I just put that on the common denominator. So my least common denominator that I'm going to need to multiply by here is going to be the 6x. Now, fortunately, this one's actually a little bit simpler to multiply out. 6x times 3 is just 18x. 6x times 2 over x. We'll make this 6x over 1 times 2 over x. I'm just going to multiply and reduce. 6x times 2 is 12x. 1 times x is x. 12x divided by x is just 12. The next one here, 6x times 5 over 6. 6x over 1 times 5 over 6. 6x times 5 is 30x. 1 times 6 is 6. 30x divided by 6, 30 divided by 6 is 5, so that's going to be 5x. Equals 6x times 5 over 3x, so 6x over 1 times 5 over 3x. We multiply 6x times 5 is 30x. 1 times 3x is 3x. Now we divide. 30 divided by 3 is 10. X divided by x actually divides out. So that's just going to be a 10. So now we have that equation to solve, which is a lot simpler than this mess. Now we'll combine 18x and 5x is 23x. We'll have the positive 12 there, equals 10. Now we're ready to solve it. We'll subtract 12. 23x equals negative 2. And of course, now we just have to divide by 23. X equals, well, rather than dividing that out, I'm just going to leave it as a negative 2/23. We might run into an example like this. So again, we have a variable on the bottom of our fraction in our denominator. We need to find the least common denominator so we can get rid of it. We've got x, 5, and 2x. Again, we're going to ignore the x and just work with the 5 and 2. The least common denominator would be 10. The least common denominator there would be 10, sorry. And then we just put the x on it. So we're going to multiply this whole thing by 10x. Again, the first part here is simple. 10x times 4 is 40x. 10x times 6 over x. Well, this will be 10x over 1 times 6 over x. 10x times 6 is 60x. 1 times x is x. Well, 60x divided by x, the x is just divide out, and that's just 60. 10x times 2/5. 10x over 1 times 2 over 5. 10x times 2 is 20x. 1 times 5 is 5. 20x divided by 5. Well, 20 divided by 5 is 4, and we still have the x. Equals 10x times 3 over 2x. So 10x over 1 times 3 over 2x. 10x times 3 is 30x. 1 times 2x is 2x. 30 divided by 2 is 15. X divided by x divides out. It cancels out. So again, we have a somewhat simpler equation here. We're going to combine what we can on each side. 40x and 4x is 44x plus 60 equals 15. And now we can start to solve. We'll subtract 60. 44x equals a negative 45. And we'll divide by 44. So x equals, well, a negative 45 over 44 will be a negative 1 and 144. 44 goes into 45 once with 1 left over. And, of course, the negative is going to stay on there. So negative 1 and 144 is our solution there. There are other ways where these can get a little ugly. We can have equations like this. Now remember, when we see this minus in front of a parentheses, we have to treat it as a negative 1 times that parentheses. The first parentheses here, there's nothing to do inside, and there's nothing to do to it. We can just write that out. We don't have to do anything with it. Here we're going to multiply by the negative 1. Negative 1 times x squared is a negative x squared. Negative 1 times negative 4 is a positive 4. This next step is the key step. We can't solve an equation with an x squared in it, but we see here we've got a positive x squared and a negative x squared. I think this is positive 1 and a negative 1 adds up to 0. So the x squared cancels out there. We have a negative 3x. 7 plus 4 is 11 equals 7 on the other side still. So now we're going to subtract 11. Negative 3x equals a negative 4, and then divide by the negative 3. X equals, well, a negative 4 over negative 3. Negative divided by negative is going to be a positive. 4 over 3 is 1 1/3. Now, just so you don't worry, there are going to be some pretty complex equations in the homework. I won't go above the middle level on a quiz or a test. I don't expect you guys to be expert equation solvers here. It's not really the point of this course. But we're going to practice them in the homework just to see what you can do, to push you to see how far you can take it. We will have equations with fractions in them on a quiz or a test. I will not do equations where there's where the variable's in the denominator. But I want you to practice them. Any of those of you that may ever go on to a 2-year degree or an associate degree or a bachelor's degree somewhere, you will probably have to take a little bit more rigorous math class, and that might be in it. So It's worth your time if you have time to practice them. So page 258, exercise 6.4, we'll have you work on 1 through 25, the odd. So we have about 12 minutes left here. If you'd like to get started, I will be on the network to answer any questions. Otherwise, that